Good morning, my dear students. How are you? I hope you're doing well, and I hope you enjoyed all my videos. And this is set exercises 7.2. I selected some problems, question 1, 3, 5, and 7, 15, 19. I would like to solve these questions with you as a revision. These questions is related with integration by parts. So all these questions we're gonna solve by using the tabular way. We have to start for integration by parts. The first example, evaluate x e to the power of negative 2x dx. I'm gonna use here the tabular way. I will make a table of two columns. The first column is for repeated differentiation. And the second column is for repeated integration. Okay, in the first column we said we're gonna use the first one, which is x, and then we will find the repeated differentiation for x until we get 0. So the derivative of x is 1 and the derivative of 1 is 0. In the second column here, it's the repeated integration, the second part, which is e to the power of negative 2x, and then and then we will find the integral of e to the power of negative 2x, which is the same, e to the power of negative 2x, and then divided by negative 2 or multiplying by negative half. Again, we will find the integral, so we have negative, it's the same, e to the power of negative 2x and divided by negative half, which is positive 1 over 4. And we said we will draw here arrows. Guys, we will draw arrows. These arrows here from x to negative half e to the power of negative 2x, and from 1 to 1/4 e to the power of negative 2x. So my answer will be equal to negative 1 over 2x e to the power of negative 2x. Don't forget the plus, minus, and then plus. Minus here 1 over 4. 1 times 1 over 4 is 1 over 4, and we have negative, so it's a negative 1 over 4 e to the power of negative 2x, and then plus what? Plus c. This is the answer of the first question. Sure, guys, here in this step we can write my answer by taking a negative e to the power of negative 2x as a common factor, and then in this case we have x over 2 plus, because we talk negative as a common factor, plus 1 over 4, and this all plus c, which is the constant of the integration. So you will find your answer like this, inshallah, in the PDF we're gonna send for you at the end of this week. Example 3, evaluate the integral of x squared e to the power of x dx. By using the tabular way, I'm going to change the color first. Let's solve by this one. Okay. We will make a table first of two columns. The first table for repeated differentiation, and the second one for repeated integration. The first one is x squared, and the second here is repeated integration for e to the power of x. X squared, its derivative is 2x, and again its derivative is 2, and its derivative again is 0. The integral of e to the power of x is e to the power of x, and the integral again of e to the power of x is e to the power of x, and one more time, which is e to the power of x. And then, as we said, guys, before in our steps here, by using the tabular way, we should draw an arrow from each entry in the first column to the entry that is one row down in the second column, like this. From each entry in the first column here to the entry that is one row down in the second column. And then 2x goes to e to the power of x, and this too. And don't forget here to label the arrows with the alternating positive and negative signs, starting with positive and then negative and then again positive. Alternating positive and negative signs, starting always with the positive sign. And let's do the answer. I'll write the answer. The answer will be equal to here x squared e to the power of x. You just multiply here like this, then minus, because my sign here over the arrow is negative, 2x e to the power of x. Okay, then again plus 2 e to the power of x, and then plus c, the constant of integration. I know that you're gonna like this way because it's so easy rather than the other way. In example 5, how to evaluate the integral of x sine 3x. Let's solve this example by using the two ways. The first way, which is the integral of the integral of u dv equals uv minus the integral of v du. And in this case, we have u, is it x or sine 3x? How to choose u? By using the word L-I-A, right? L-I-A-T-E. T-E. So here we're gonna choose first the a, which is x, the algebraic function, and its du will be equal 1 dx. This is the first part to find u. The dv equal, it's a sine 3x dx, right? And the integral for both sides, the integral of dv is v, and the integral of sine 3x is negative cosine 3x, and this all over 3. This is the value of v. Then I'm gonna try here to apply the rule, which is u which is x, and v this all, so it's a negative x over 3 cosine 3x minus the integral of v, which is positive now, since a negative is positive, 1/3. I will put here 1/3 as a constant, cosine 3x times du. The du is dx. The du is 1 dx, it's here. Then it's equal to negative 1/3, or is x over 3 cosine 3x plus 1 over 3, and the integral of cosine is sine 3x, and this all over 3 plus c, which is the constant of integration. You can handle your answer and write it as negative 1/3 x cosine 3x plus 1 over 9 sine 3x plus c. Thank you. This is the first way how to use the rule, which is uv minus the integral of v du. But I would like to solve by the second way. So I'm gonna copy again the question. What's the question here? We change the color here first. Yes, and again here, where is the question? The question is the integral of what? It's x sine 3x, right? The integral of x sine 3x dx. I think so. Yes, it's correct. So I'm gonna solve this question here by using the tabular way. I will make a table, and here the repeated differentiation, and here the repeated integration, and up here x, and its derivative is 1 and then 0, and the integral of, and up here sine 3x, its integral is negative cosine 3x, and this all over 3. Over 3 is the same as multiplying by third, and here is negative. And then again it will be here negative 1 over 9 sine 3x. And then draw your arrow, your arrows. Draw your arrows here, such that draw your arrows like this, from the first entry in the first column to the second entry, one row below in the second column. So don't forget also your signs in alternating way, positive, negative. So it's positive then negative. Finally, let's write our answer here. The answer is negative 1 over 3x cosine 3x. As I said, for you should start from here. X, and it's positive, times negative is negative 1/3 x cosine 3x, and then negative times negative 1, sure, by negative 1 over 9, which is positive 1 over 9 sine 3x, and don't forget your constant of integration.